Hello everyone, welcome to Technologies Discussion Channel. Okay, today I'd like to continue the discussion on phase lock loop. On my previous video, I actually have explained the components that are required to build a phase lock loop. This video, I'm going to explain the working principle of phase lock loop. So this will be the objective of this video. I'm going to explain how does this phase lock loop actually works. This will be the part 2 series discussion on phase lock loop. So guys, if you're keen to know more about phase lock loop, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on phase lock loop. This is my email. If you have any question regards on this discussion, please drop me an email. If not, I strongly urge you guys to ask your question through the comment. Okay, so this is because I hardly check this email. So guys, if you want to have a faster response, okay, ask me through the comments. I also urge you guys, okay, to give me some suggestion of topics that you guys are keen. Okay, so basically this will actually increase the quality of this channel. Okay, before I continue, I'd like to urge you guys to help this channel by like this video. For those who are new to this channel, please consider to subscribe to this channel and turn on your notification bell. Once again, thank you so much for strong support. Okay, let's quickly understand how does this phase lock loop actually works. Okay, before I go into detail on phase lock loop, okay, let me explain what is actually a phase detector. As you can see that the phase detector is actually the first stage of phase lock loop. Okay, so a phase detector, they are also known as a phase comparator. So basically what they actually do is basically they compare the two waveform, they compare the two input waveform, and at the output of the phase detector, basically they represent how much will be the phase difference of the input signal. So in short, okay, if these two signals they are correlated, then you will not see anything at the output. And if there is any phase difference between the two input F reference and F in, then you will see something at the output. Then you know that there is actually a phase difference between the two input signal. There are actually two basic types of phase detector. Okay, the first one, okay, which I'm going to do a little bit more discussion for this video, is on the sinusoidal phase detector. And the other one is actually the square signal phase detector. Okay, for this square signal phase detector, they actually operate either in binary mode. Okay, so I guess you know that for square, basically they are like a digital signal. So they can operate either in binary mode, or you can actually detect them through the zero crossing, okay, which means that they actually cross the zero. Okay, so this I will explain later on. Okay, the phase detector actually provide a series of output pulse whose width is proportional to the phase difference. Okay, I'm going to explain this a little bit more on the next two slides. Okay, but over here, you keep this in mind. Okay, basically at the output of the phase detector, they will be so-called show how much the difference in between the phase of these two input signal. So as I mentioned earlier on, the more phase difference, it will so-called more significant display at the output. Okay, so again, okay, I will use a diagram to explain this point. Okay, let's quickly understand. Okay, so as I mentioned earlier on, okay, for this phase lock loop, okay, you can see that we actually have this sinusoidal phase detector. We also have this square signal phase detector. Okay, for this case here, which I present is belongs to the square types. Okay, so basically you can see that this is a example of a lock phase. You can see that the F reference and F in, okay, which is the two input to the phase detector. Okay, all the signal they are all in phase. So basically at the output, you will not be able to see anything. Okay, which means that at the output of the phase detector, it almost flat, nothing you can see because the F reference and F in, they are actually all in phase. So next, okay, I'm going to show you another example, which is the unlocked phase, okay, which means that there is actually a phase difference between F reference and F in. Okay, and over here you can see that at the output, okay, they basically highlight, okay, where is the position that has this phase difference, as you can see from here. So in short, you can imagine this. okay, the larger the phase difference, imagine this shifts more to the right. Okay, again, you can see that this output will be so-called thicker. So in short, like what I mentioned earlier on, the more phase different, okay, the more you can actually show it at the output. Okay, so basically this is actually an example of unlocked phase, okay, basically based on the binary types or the square signal. Okay, so next, okay, let's move on to the sine type. Okay, so basically for sine type, you can see that basically this is under the lock phase, okay, which means that the phase of the F reference and the phase of F in, they are actually all in phase. Again, from here, you can see that nothing displayed at the output over here. So another example, okay, will be the unlock phase. Okay, so basically unlock phase, which means that F reference and F in the phase, actually there is some slight difference. Okay, again, from here you can see that the difference is actually highlighted at the output of the phase detector. So basically, in short, if you don't see anything at the output of the phase detector, which means that F reference and F in, they are actually in phase. But if you see something at the output, which clearly indicate that F reference and F in, they are actually not in phase. And another criteria you can consider is the bigger or the so-called the width actually become so-called larger. Okay, the more that this F reference and F in the phase, the more they are actually so-called out of phase. So in short, basically, the key idea is how to make this output become thinner and thinner and thinner, and finally they are actually locked. So basically, this is the role of a phase lock loop. Okay, let me explain in deep detail. Okay, so as I mentioned earlier on, let me emphasize on the sine type first. Okay, so basically these are the two input that is so-called mainly for this phase detector. Okay, so since this is a F reference, this is a sine wave. So you can see that the sine wave had this so-called signal to describe a signal at the input of the phase detector, which is sine 2 pi F reference here. Okay, so this is F in. So basically will be known as sine 2 pi F in here. So basically these are the two input, they combine, okay, through the phase detector. So at the output here, you can see that it's actually the F reference multiplied by F in, as you can see from this equation here. So at the output of the phase detector is simply the multiplication of the two input signal here. And if you still remember, these are actually by mathematics. Okay, I actually can describe this signal in a mathematical way. So basically, at this part here, basically this signal will appear at the output of the phase detector. Okay, so next, this is actually a loop filter, or in short, this is actually a low pass filter. You can see that there are actually two frequency components. This is definitely having a much lower frequency as compared to here. Okay, remember, since this is a low pass filter, so therefore, basically this part here will be able to pass through the filter, while the filter will actually remove this term. So therefore, at the output of the low pass filter, I actually have less, so-called, I have left this item here. So basically, this whole part here, they went through the low pass filter. The high pass component actually will be filtered away, and at the output of the loop filter will be this term, which is highlight over here. So basically, this term actually is fed through this VCO. Okay, so what does the role of VCO do? Okay, you can see this diagram here. So basically, again, you imagine, let's say they are all in phase. In phase means that F reference minus F in, they are so-called the same frequency, then this term will become zero. And basically from here, you can see that once they are become zero, they were under the lock phase, as you can see from here. So this is actually under the lock phase. So once they are all equal, and when F reference minus F in is equals to zero, then they will be under the lock criteria. Okay, so another criteria, imagine this, F reference minus F in become a positive number. Okay, which means that F reference is actually bigger than F in. Can you imagine this? Okay, because F reference is bigger than F in, so therefore this is a positive number. And imagine, let's say, okay, it's one of this line here. Okay, imagine there are lots of line here. Okay, so this is the maximum, this is the minimum. Okay, just imagine that actually this voltage is actually over here that indicate the phase difference between the two input. And what happened here is basically you can see that they will generate a higher frequency. So which means that this frequency actually increase. Since F reference is bigger than F in, so therefore I need to increase the frequency. So basically this is done by the role of a VCO. So basically at the output, okay, of the loop filter here, fed into the input of the VCO, and if let's say F reference is bigger than F in, then this will be the scenario, and based on the voltage value, okay, another set of frequency will be generated at the output of the VCO. And again, this thing will continue, and they basically will do the phase detection again. And this thing will go on and on, okay, until F reference is so-called in phase with F in. Then this will be loop. Okay, so which means that it will become a phase lock loop, which means that it will have a constant so-called frequency at the output of the phase lock loop. Okay, I hope this is clear. But over here, just quickly go through. Let's say F reference minus F in. Let's say this is a minus number, which means that F reference is a smaller frequency as compared to F in, which means that this is actually a bigger number as compared to the F reference. So we need to reduce the frequency. And if this is minus, imagine this is minus here, then the frequency will be smaller than the norm. And because of this, again, okay, they will do this repeat many times until the signal is locked. Then this will be a phase lock loop. Okay, so with this, okay, I hope I seek your support again to like this video. And if you have learned something from this video, please guys, help me by subscribe to this channel and turn on your notification bell. Okay, with this, that's all I have for this video. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.